So today on the bench I've got this inverter. It's a 500 watt inverter called the Traveller, and it takes for the input 12.8 volts at 46 amps, and it's supposed to be a 500 watt out. It's also got a 2 amp or 2.1 amp USB output on it, so at 5 volts obviously, and it doesn't work. Surprise, surprise. I did put 12 volts on here and it did nothing, and so we'll investigate, see what's going on. Looks like there are 4 screws here, so I'll take these off first of all, get these out of the way. Get these screws out of here. Looks like there's self-tapping screws into what would be plastic pillars at the bottom there. Well, looks like these side pieces have to come off. So let's see. Oh, there we go. There's one. Two. Hopefully it'll separate. Oh, there we go. All right. Spring-loaded button there. So, put that to one side. And take a closer look. Well, I see 2 30 amp fuses down here straight away, which will be probably the first thing to check. See what's going on with those fuses. Uh-oh. Yeah, those fuses are blown. Okay, so we've got to get a little more involved, a little more serious with this thing. I see some semiconductors down here, actually on either side. Yeah, here we go. Can't tell what they are because they're covered by the clamp. The clamps them against the heatsink there. But there's some more down here too, on either side. Yeah, Those do have visible numbers. Let's get some magnifiers on it. IRF 1404. And this one. Looks like it's covered with some heatsink compound, but maybe the same. Yeah, IRF 1404, whatever those are. Not sure. Not without taking this out and having further investigation. So I think maybe I'll do that next. Take the board out and have a closer look. Looks like it's released the board. Now I need to. Well, the fan just plugs in, so it's easy enough to. That's easy enough to separate. And there's a couple of little nuts holding the supply, so I'll just loosen those. Didn't feel very tight actually. That one side. It's a little tighter than finger tight. Now they're loose. Okay, we've got those. Cut those off and unplug the fan. And that board should come out. Okay. There's a big blob of solder here that, oh, it's just the way the negative terminal was, the wire was cut flush through the wire and actually cut the wire through the solder. It's not very good, but I guess it was holding it tight. So let's see what these semiconductors read. I'm not having a lot of hope for these, but we'll see. These might be alright. See what these guys read. Yeah, they read short. Yeah, these fuses are completely blown. Let's take those fuses out. Looks like this center terminal on this semiconductor isn't even soldered to anything, which seems a bit odd. That's that 1404. I mean, it could be just a diode or a double diode or something. I don't know, it's weird though, because unless I'm... No, that's that semiconductor. And the center terminal's not even connected to anything. And this side is connected here, but that side doesn't have a connection at all. Which is really weird. Huh. Strange. Anyway, I'll take these fuses out because they're dead anyway. That might be a bit better for sound because I turned the fan off. Yeah, okay, so these fuses are definitely blown. You can actually see through that they're blown. They have little sleeves on them, little like thermal protected sleeves on the pins. Like little fiberglass sleeves on those pins. And, just to double check, which I don't think I need to, but yeah. Yep, they're both blown. And they're two 30 amp fuses, which I do have some 30 amp fuses like this. They are sort of car fuses. Often you'll see these spade fuses in vehicles today. So, like magic, ta-da! More fuses. So, I had to replace some fuses, but not much point putting those fuses in yet because we know something blew those fuses. I suspect the semiconductors on the board here are the ones that took the fuses out. Yeah, they both look like they're blown. Let's unscrew these for the moment. Separating them from the heatsink might also give us a different reading. Nope. Oh, actually it does. Interesting. All right, so if we follow this around, this is our negative supply from the 12 volts coming in, and it comes down to this terminal and this terminal, and if we read across there, we've got a direct short. Let me get a relative reading on that. 0.5 of an ohm either way. This, however, is not reading short circuit any longer, since I took the screw out that was bolting it to the heatsink. So that one is possibly okay. That's a 1404, I believe. This one, however, looks like it's short circuit, so I think I'm going to pop that one out. Get my desoldering gun working. Okay, let's see if we can get this little one out here. Looks like it needs some regular solder on there. Lost it. Okay. These things need cleaning constantly. They will clog up very quickly. They're something that you got to be constantly cleaning, because they do clog up very easily. Alright, I think this should come out now. Yep, there we go. So it looks like it's an IRF 1404. So let's check what it's going to give us. I think it's short circuit, whatever it is. Yep, that's short circuit. Let me put the screw back on the other side. See what we get this time. Doesn't have a lot of heatsink compound underneath that device, so probably wasn't getting very good heat transfer. But see if we still have a short now. Oh, actually we don't have a short. There's capacitor charging on that, across that device. I don't know whether you can see that on the video. I'll move this over a little bit. You might be able to see the display, but if I probe across that that other 1404, you'll see the capacitor charging. There we go. And then if I reverse the wires, you can actually see the capacitor charge and discharge. So when you're checking for shorts, it's always a good idea to hold that connection a little while, you know, 10 seconds or so, just in case there's a capacitor that gives you the impression there's a short, but in reality it's just the capacitor charging up. So you have to, you know, just allow for that, because sometimes you will find initially it sounds like there's a short, but in reality it's not, it's a capacitor charging. All right, so far so good. One burned out semiconductor and 2 fuses so far, and maybe that's all that's wrong. Yeah, we might be lucky. There's this one. No, maybe not. There's some semiconductors down here, and I'm seeing a short. seen a short across these two pins. Now I can see that the one pin that where I'm reading a short, there is the connections to the transformer. So I might just be getting a false indication because the transformer is connected here. So obviously we're going to get some indication of a short circuit because of the transformer windings. That looks like it might be short circuit. No, maybe not. I was just saying about capacitors, and I think that was a capacitor charging. Oh, okay. All right, so far so good. So I'm going to put the fuses in, mainly because I want to do some checks across the input, see if I've got any direct short still across the input, because until I replace the fuse or put a link across there, doing some continuity tests, it won't give me shorts. I can check from here to here. Again, we've got a capacitor charging, so that's good. Yeah, so looks like the short has gone, and I assume that was the short from here. So yeah, I'll put those fuses in and do some continuity tests. Let's put these little fireproof legs. Put that in at the back there. They don't seem to want to go in very far, those fuse. That's a little better. Yeah, it's got it this time. Fireproof legs. Fiberglass. I think they're fiberglass sleeves. solder that in. And for those of you that are curious, yes, it is leaded solder. I apologise for the noise of the fan, but it's so hot in here right now. I need to have that fan on. Alright, so we got the fuses installed. 2 fuses. 2 30 amp fuses. And let's see what we've got here. If you put the meter on. There's not a Prime Minister name. Meter on. Alright, so buzzer. Supply. No short. That's a good sign. No short. Check the other way around. Still no short. Maybe it's just that 1404, which I need to find out what it is and find a replacement for it. So it appears that this is an N-channel MOSFET. And we've got a gate to, I think it was source, short circuit on here. I'm still puzzled why that center pin is not connected, or doesn't appear to be connected to anything. That to me doesn't make a lot of sense, but that's beyond me right now. I would have to look into that in a bit more detail. So I've got to order these and come back to this. So for now. So remember I said there was no connection to this center pin here. Well, what they're doing is they're using the tab of the component. So they're using the metal heatsink tab as a connection. So that forms the one connection, which is why they're not bothering to solder this center pin. So they are actually using all 3 terminals. It's just they're not soldering this center one, they're using the tab instead. So I did some further checks on these two, and once I took this out the board, I found that it was actually shorted. All the terminals were shorted, so this one's totally short circuit. This one, we've got a short between this leg and the center terminal, or the tab, so they're both faulty. And well, it's another day and the 1404s have arrived, so I can replace those. The IRF 1404, and let's see what happens after I replace those. Put all the bits in this box. Get these back in place. Actually, I'll put a little bit of thermal paste. Yeah. Let's put a little spot on there. Shouldn't need much. Just a little spot. In each position. top back on there. Put it there for now. Okay, these are N-channel FETs, by the way. Just test them there. Yeah, N-channel. I did download the datasheet for these just to see what they were before I ordered them. So they seem to test out okay. The hole, I think the centre hole's a little bit jammed up, possibly. Let's see, what have I got? Maybe a bit of wire. Maybe I can use a bit of wire to clear that hole out. The wire that I've cut off something previously. Yeah, that hole's free. That one, it's the centre one that's it's not free, or not allowing a leg of this FET to go through. Let's cut that at an angle. Otherwise I'm going to have to get a little drill to clear that hole out. Oh, ha! Okay, that's why it doesn't. That's why it doesn't allow it to go through. There's a wire in the hole. Yeah, they stuffed a wire in that centre hole, so that's why it doesn't go through. So I need to shorten this centre leg because it doesn't need to pass through. That would explain why this one has the centre leg cut off short, which I'm a little surprised at, but well. No, it should go in with a little bit of persuasion. Come on. It's a little fiddly. My fingers are big. Too big. A bit more light on the subject might help. There's also some there's a compound of some kind down there to it's not a heating compound, it's like a glue which is blocking the hole a little bit. There we go. Let's cut that out of the way. That might help. There we go. That's better. Yeah, let's spread the heatsink compound around a little bit. Let's do the same this side. This one, I think, yeah, this is all, oh, well, actually, although the hole is clear for the center pin, there's no pad there. So it's only using the case for its center connection. So it doesn't need the center pin, but it's going to go through the, I'm going to put it through the hole anyway. There we go. So that's that. Through the hole. And just put the screw in there to hold that in place. And that spread the heatsink compound around nicely underneath that. Okay. So let me solder those in place. What could I do with my solder? There it is. Not sure whether you can see right now, but I'm just soldering those two FETs back in. And the center wire that's okay, they're back in. And I think I'm going to do some tests now, see what I can see in terms of any shorts on the input now. I shouldn't see any shorts, but who knows? Let's see what we got. There's the input terminals. That's the capacitor charging up. Well, that looks good. So far, so good. Just reverse those terminals just to see. Another capacitor charging up. Alright, so that looks good. Not sure what, well, I guess it takes 30 amps, up to 60 amps actually. So maybe I'll put a current limited supply on that and see. I've got it hooked up to a 13 volt 20 amp supply, and I'm going to power it up, see what it does. I'm not expecting it to do a lot, but we'll see. Let's put that on AC volts and see what happens. Alright, it's going into current limit. It hits 20 amps, well over 20 amps, goes into current limit, shuts the power supply down, and then this resets every time. But we're getting some sort of output on the AC side, so that's a good sign. Not sure if I can get a better idea of the voltage here. Oh yeah, that hit over 50 volts, so it's getting up to about 60 volts before the current limit cuts in. So yeah, that's getting pretty warm pretty quick. Mind you, the fan's not connected up either, so there's no fan to cool that down. Whew, yeah, that's getting pretty toasty. So I found something else wrong with this. I noticed there was some charring at the bottom of this FET, and there's a 15 ohm resistor. Well, I'm assuming it's a 15 ohm resistor. The reason I say that is there's a matching circuit on this side of the inverter. So there's a 15 ohm and a diode on this side, and the resistor numbers seem to match up. And so I looked down here at the resistor and it was charred, and so I've got the charred resistor down here, and this one was measuring like 500 ohms, and it was actually fluctuating. It wasn't a solid resistance. So this was burnt, so I took that out, replaced it with a 15 ohm down here, which is difficult to see. I don't know whether you can see that, but anyway, I put a new resistor in down here, and so I'm going to try it again on the bench here before I actually put it on a full current supply, just to see what it does, because it seemed to be taking a lot of current without any load. I mean, it was over 20 amps and I was taking no load out of it, so that didn't seem right. So before I put it on a full load, I thought, yeah, that doesn't seem to be quite right. So I had a look around and I spotted that charred resistor, and so I've replaced it, and I'll check it again on the 20 amp supply and see what happens. Make sure I get the polarity around the right way. Okay, let's measure the AC. Measure the AC supply, or the AC output I should say. See what we get out of there. So 12 volts, 12 volts at up to 20 amps right now. Let's see what I get out. Everything's connected up okay. Put the supply on, it would help. $119 volts, so 119 volts AC coming out, so that's a good sign. And we're only drawing 200 milliamps DC. Wow. And it's not current limiting, obviously, because it's only drawing 200 milliamps. That is a lot more like I would have expected. A fair, well, not such a low current draw, but it is a low current draw. But 20 milliamps, sorry, 200 milliamps at 12 volts and 120 volt out. So let me put a load on it and see what that does. A load here I can try it with. See that? Just going to put a low load on there. What have I got? I've got some bulbs here. Let's say 7.5 watt, I think. It's pretty low by the looks of it. So everything's on. 120 volts out. Woohoo! It's working. It's cool. Okay. That's what does the load go up? Sorry, what does the current draw? I'm drawing 800 milliamps now with a 7.5 watt load at 120 volts. So let's see, I have a what do I have? I have a, I think it's an 11 watt. What's this one? 72 watt. Oh, so it's a 72 watt halogen. Okay. I'm not sure what the maximum load I can put on this. Of course there's USB output on there as well. I should check that, but before I do that, oh, it's okay, so it's a 500 watt inverter, so it should easily take this 75 watt as long as it doesn't overcurrent the power supply. So let me turn it off, put the 75 watt load on there, see if it goes bang. Whoa! And the fan's going. Great. Nice. And what current was it taking? Taking 6.5 amps at 12 volts. It seems to be happy with that. Putting out 114 volts AC into that 75 watt bulb. So what else have I got here to try? Got some more bulbs here I could try. That's 100 watt. Try 100 watt load. So 100 watt. Here we go with a 100 watt load. You can see that voltmeter just about. 100 watt load, here we go. Yeah. Taking 9 amps. Alright, so what else have we got here? I've got a 150 watt load. So let's try 150 watt. At some point it's going to overload the power supply over there, or someone else is going to go bang. But right now, yeah, it's not getting too warm. That's good. Alright, so what have we got? 150, I think that's a 150 watt load. So let's see what that does. 12 amps, 12.25 amps. 113 volts out. 150 watt. 150 watt load. It seems to be working. Seems to be working well. So, got a couple of indicators on here. I'm trying to work out low voltage, overheat. Okay, so that's just showing the lowest load indicator right now. The first indicator on the bar graph, because it's only a low load, so small load. So anyway, looks like it's working. So I think I'm now going to reassemble it properly and try it again. These things are very sharp. Okay, let's get this back together while I can remember how it goes back together. It's pretty rusty. I could maybe clean these up a bit. Put them on a wire brush, clean them up. Actually, I think I'll do that before I give it back. Okay, I put these on the wire wheel and cleaned these up a bit because they were getting pretty tatty, pretty rusty. I think maybe some battery acid had got on them or something, but they're like cleaner now anyway, so they're cleaned up. Get this reassembled. Okay, so one more time. Let's put the 12 volts back on here. And see what happens. Okay, drawing 200 milliamps. Let's give it a load. Let's try the 150 watt. I think that's the biggest one I've got. Might have a 200 watt somewhere, but this will do for now. Alright, so give it a 150 watt load. I don't know why it's beeping at me. It wasn't, I don't remember it beeping before. Let's try a smaller load. I wonder if it's getting a volt drop across the... Let's turn that up a shade. Let's give it... yeah, because these wires are quite thin, so let's turn that up a bit. Give it about 13 volts. Right, that's 13... Just a shade over 13 volts, so see what it does with that. That's better. So I think that was saying low voltage, but it didn't seem to be giving an indication here of low voltage, but that's 11.3 amps at 13 volts. And it's driving the 150 watt load. Okay, I think we're going to call that a win. So that's the Traveller 500 watt inverter by Intertech, model 1054455. Okay, well, thanks for watching. If you enjoyed the video, give me a thumbs up and subscribe for more videos. Thanks again. Bye for now.